In this video, we'll look at a graphical representation of a function. For this example, we've got a population of bees happily residing in someone's backyard. Let B of t be the size of the bee population in thousands, t months after April 1st, 2012, which is shown in this figure 1. Evaluate the function b at t equals 3. Explain what the function value represents in the context of the problem. Okay, so when it says evaluate the function b at t equal 3, remember that we have b of t versus b of x or something else. So when it says evaluate the function b at t equal 3, what is it really asking us for? It's asking us for b of 3, right? Since t is the input. Okay, so if we have an input of 3, that generally is associated with the horizontal axis or the x-axis. Okay, so if I go over to where x is 3 and go up on the function till I hit it, right? So it looks to me like that happens where? When the y value is 15. Okay, so b of 3 equals 15, and then of course it says explain what this function value represents in the context of the problem. Well, if the input is 3, and that represents the months after April 1st, 2012, in, let's see, April, May, June, July would be 3 months later, right? So on July 1st, 2012, there will be 15,000 bees in the backyard, right? Then in part B, it says evaluate b of 0. Explain what this function value represents in the context of the problem. With b of 0, that means the input value is 0, right? So essentially let x be 0, and then what is the y value when x is 0? So that gives us the y-intercept, right? Which is 10. Okay, so we know that b of 0 is 10, and then of course it says explain what that means, what it represents in the context of the problem. I would say on April 1st, 2012, right? Because that's the x-axis represents the number of months after April 1st, 2012. So April 1st represents t equals 0. There will be 10,000 bees. So instead of having an input and finding the corresponding output, we have it the other way around, right? So in this case, we're given an output and we need to find the corresponding input or inputs that makes this true. It says solve b of t equal to 13 and explain what the solution set represents in the context of the problem. So the first thing that I would do, since I know the output value is 13, I'm just going to draw a little horizontal line right here at 13. And that crosses the function in 2 places, right? So I know that 13 represents an output, so that's why I went up on the vertical axis there. And I'm just going to figure out what are the corresponding values on the horizontal axis, or the t-axis in this case. So when t is equal to 1, or when t is equal to 5, the y value is 13, right? So, and we can denote those solutions in a set, right? So we could say the set of 1 and 5, those are both going to satisfy that equation of b of t equal 13. So what does this mean in the context of the problem? So it basically means that there were 13,000 bees at 2 different times after April 1st. I would say there were 13,000 bees a month after April 1st, so on May 1st, 2012, and on um, September 1st, 2012, right? Because September is 5 months after. Okay, great. And a similar problem. So solve b of t equals 0. So now the output is 0. So that's down here along the axes, right? Along the horizontal axes or the t-axis. All right, now this only has one solution, right? T equals 9, okay? If ever you're asked to put your solution in a solution set, you can certainly put it in set brackets, and you can even have a set with one element in it. That's okay. Okay, and so what does this represent? Well, it means that the bees are completely gone, wiped out, um, 9 months after April 1st. You can say that, or you can come up with the exact date, right? So I'm thinking a month after April, we're at May, June, July, August, September, October, November, December, January. On January 1st, 2013, um, there are no more bees. In the winter they disappear, right? So, but at any rate, that's the idea. So hopefully that makes sense. If our output is 0, that represents a horizontal intercept, right? And that happened at 9. So 9 months after April 1st, 2012, the bee population was completely gone.